In this video, we quickly learn how to use the TI-84's built-in t-interval function to compute a one mean confidence interval when we're given the summary statistics for the sample. In other words, when we're given the mean and standard deviation of the sample. So in the example problem, we're told we have a sample size of 18 adults and their resting heart rates are measured, giving us a sample mean of x bar equals 69.61 beats per minute with a standard deviation of 6.35 beats per minute. And we're asked to find a 95% confidence interval here. So we head to the TI-84 and we hit the Stat button. We arrow over to Tests and then down to T-interval and hit Enter. And then in this top line, we want to select Stats here to indicate that we're using summary statistics instead of a list of raw data for this problem. And we put in our mean. That was 69.61 and our standard deviation 6.35. And remember, N stands for the sample size, so that was 18. The default confidence level is 0.95, so that's good, and we calculate. And so our interval pops out in interval notation as 66.452 on the low end up to 72.768 on the high end. So we'll go ahead and round that confidence interval to a low end of 66.5 beats per minute and a high end of 72.8 beats per minute. Now, sometimes we'd rather express this as the sample mean value plus or minus a margin of error. So to get the margin of error, we just take the interval width and divide it by 2. So the interval width is 72.8 minus 66.5, and we can divide that by 2, and we get 3.15, and I'm just going to round that off to 3.2. So the margin of error, also called the error bound for the mean in some books, is given by about 3.2 beats per minute. And the same confidence interval can then be expressed as 69.6 plus or minus 3.2 beats per minute. In the next video, we show how to use the t-interval function to generate one mean confidence intervals when we're given raw data instead of summary statistics. I'll post a link to that video at the upper left, and I'll see you there.